In this video, we'll continue Lesson 1-1 examples 3 through 5. First off, start by seeing this diagram where we show positive, negative, increasing, and decreasing of this parabola. We need to remember that increasing has to do with the slope being positive, as it is in green here. Decreasing in this function would be the orange, where the slope is negative. Positive parts of a function refer to where it's above the x-axis, where it has positive y values. Negative y values, or negative parts of the function, are when it's below the x-axis. These can be confusing, and if they're interchanged, can cause you to get these following examples incorrect. For example 3, they want to know when x squared minus 9 is positive and negative. Remember, that means positive y values. So above or below the x-axis. You may use any graphing device to view this graph, but here I have a picture of one, x squared minus 9. It is positive when it's above the x-axis, or it has positive y values. Now, we want to indicate this zone that it's positive by using the x values. So we'd say, starting at 3 and going on to infinity, it'll stay in the positive region. So for positive, we would say from 3 to infinity. But notice that it's also positive back here. That's from negative infinity up to the x value of 3. You might see this union sign to indicate that there's two intervals united to make this total solution. So we'd say from negative infinity to negative 3. Notice how they each have soft brackets. We'll talk a little bit more about this. The infinity will always have soft brackets. But with the negative 3 and the positive 3, we'll discuss more about why that is in just a moment. When is it negative? That's, of course, when it's below the x-axis, when the y values will be negative on this function. So here, that's between negative 3 and positive 3. So we put our lower number first and our upper number second. The reason we use soft parentheses around any of our 3 or negative 3 values is, right when x is negative 3 or x is positive 3, the actual value is neither positive nor negative. It's 0. So we don't include that in any of our solutions. That's where this common error comes in. We would never include the zeros as positive or negative. For the try it, when is this function 2x plus 10 positive or negative? I'll look again at another graph here. This one's just linear. Positive, again the y values are above the x-axis when they're positive, so negative 5 seems to be our 0, our cutoff. It's positive from negative 5 to infinity. Again, we're using those x values to indicate our interval. And when is the function negative? That's from negative infinity to negative 5. Now we turn to examples of when a function is increasing and decreasing. Remember, increasing is when the function is sloping positively, where decreasing is the function's sloping negatively. Not to be confused with when the function is positive and negative, having to do with y values. So we would graph this function, but before I do that, I want to take a look at this table, because they ask about using a table, and if we don't use it now, we may never need it. But we're going to use the table to graph it, and then we'll check our answer. So if I plug in a 0 on this function, 2 take away 0 would be 2. If I plug in 1, the absolute value is 1 of 1. 2 take away 1 is 1. If I plug in negative 1, I get the absolute value of that is a positive 1, because remember, absolute value essentially just changes everything and makes it positive, whether that's a positive number or a negative number. It has to do with the distance you are from 0. So if I put in a negative 1, that's actually going to become a positive 1, and 2 take away 1 is 1. If I put in 2, 2 take away 2 is 0, and 2 take away 2 again, because the absolute value of negative 2 is positive 2, will also be 0. I'm going to go quick and graph these points. I've got 2, 0, 1, 1, 0, 2, negative 1, 1, negative 2, 0. You can get the basic idea of what my function is going to look like here with my absolute value graph. Let's talk about when it's increasing. It'd be increasing when the slope is positive. Here's where our positive slope is. So it's increasing on this side, and it's decreasing on this side. We're now ready to answer the questions they asked. But just for fun, let's see if we graphed it right. I'd say those look pretty darn good. For increasing, we'll use our interval notation. It is increasing from, now remember we're using our x values. It's increasing, if I kept drawing this, it's going to be increasing from negative infinity all the way up to, don't say 2, we want to use the x value here, that's 0. So from negative infinity to 0. It'd be decreasing then from 0 to infinity. Once again, notice how our 0 uses parentheses because it can't be increasing and decreasing at that very top. It's really doing neither. Answering the same questions here on Try It, we have increasing and decreasing values. Again, they even give us that hint, what values of x. So we're only looking at the x values. I'm going to use my handy-dandy grapher here for x squared minus 4x. There's my graph. It is increasing on this side of the graph. So starting at positive 2. Because remember, we're counting over here what x value does it start increasing at. So this one would be increasing from 2 to infinity. All the way up here, all these x values have increasing slopes. And it's decreasing from negative infinity to 2. For this graph over here, negative 2x minus 3, note that it's just a line. It is decreasing all of the time. So it's never increasing. NA, not applicable. It's decreasing always, negative infinity to positive infinity. For average rate of change, you're basically looking at what is the change in y over the change in x. We referred to this as slope before, but a lot of times slope has been found from 2 points on a line. Say this is 1, 3, and this is 4, 7. To find the average rate of change, well, it's changing at a steady rate as you walk along there. So the average rate of change has been the same as the slope. But when we bend our curve, we still can use that same slope idea. It's just that it's averaging out because it's not changing. The slope of the line right here is not very steep. But if I took the slope of the line right here, it's much steeper. We're essentially going to average out those slopes along that curve between the 2 points. So just as slope was y2 minus y1 over x2 minus x1, another way to think of that, these y values can also be written as f of b minus f of a over b minus a. What that means is when you had an a value here, you would plug in that a value or x value to get your y value into your function. So you'd plug a into your function. Or b here, you'd plug b into that function to get your y value. So I've kind of given you the answer there, but for this example 5, when they want you to find the average rate of change using these values, your y value is here and here. Those are the y points that you're using between those 2 points. So you would take one of them, so we'll say f of b minus f of a. It's essentially y minus y, divided by your x values, which are b and a. It is important that I'd go in the same order, which is why I'm going to go b minus a. And that's really all they want for part A. For part B, we want to find the average rates of change, so essentially the slope, over the given intervals for each of the functions. So from negative 2 to 0, remember these are the x values of the function. So on this graph, we look at negative 2 to 0, the average rate of change. So we can kind of tell the slope there right off the bat is going to be 0. But if we use those values, the y values are 1 on this point, negative 2, 1, minus y value here is 1, over negative 2 minus 0. Well, 0 divided by anything would make 0. And that should make sense. We're going to go ahead and go down the rest of these intervals here because no matter where we go, this line is flat. The slope, or average rate of change, is always going to be 0. What does that tell us? This is a flat horizontal line because the average rate of change is always the same. Now, for our orange graph here, we want to find the average rate of change from negative 2 to 0. So here's our negative 2, here's our 0. We're going to use our x and our y value. So I'm going to start with this bottom point first. I'll take negative 2 for the y value minus negative 1. There's my y values I'm using. It's important to have the minus sign and the negative 1 there. Over my x value changes, negative 2 minus 0. So that will give me, remember, subtracting a negative is like adding. So we're going to have negative 2 plus 1 is negative 1 over negative 2, which gives me 1/2. If I do it for the other interval from 0 to 3, I'm going to be using these 2 points, this one and this one. 0 and 3, again, are my x values. So I would have my y value here at negative 1 minus my y value up here of 0.5 over my x value here of 0 minus my x value there of 3. Negative 1 take away 1/2 is negative 1.5 over negative 3. A negative divided by a negative, again, just like up here, is a positive. And 1.5 divided by 3 is 1/2. Now, it's not going to be surprising to say that this last interval is going to be the same answer because this line is the same steady slope. Now, in speed form, here would be our actual slope. And boom, there you have it. So I used this first point with negative 2 for x and this last point with 3 for x, found the slope of change in y over change in x, and I got the same answer. So again, this is just a steady 1/2 slope line. It's linear because the slope stays the same, but that's what we know about the function, and we can visualize that as well. All right, finally we have our intervals for y equals x squared. If I go from negative 2 to 0, my negative 2x value to 0, and find the slope, I'll do my 4 minus my 0 for the y values over negative 2 minus 0 for the x values. And that gives me 4 over negative 2, which means an average slope of negative 2. Now, just for a second to visualize that, here's what that means. The slope between those 2 points, the average slope of that would be negative 2. Now, we're going to do that again with 2 different points here. So the next one is from 0 to 3. Okay, so from 0 to 3, here's our x is 0, here's our y of 3. We're going to find the average rate between these 2 points. I'll take my y9 minus my y0 over my y3 minus my x3 minus my x0, and 9 over 3 gives me 3. Interesting. For once, it didn't come out the same. Our final interval in our magic form would take our y here minus our y there, so we'd have 9 minus 4 over x minus our x, so 3 minus negative 2. Remember, when you subtract a negative, it becomes adding, and 5 over 5 is 1. The fact that these are all different, we have a decreasing slope here and an increasing slope here and a positive slope here, but it just tells us that this is not a linear function, which of course we could see, but that's because of slope changes. Now we're almost out of time, but if you look at this graph, starting when x is negative 2 to 0, we have a negative slope. From 0 to 3, it's positive, and from negative 2 to 3, it's positive but not as steep. That would just tell us that this is not a linear function. The average rates are changing.